We're back. Lunch review number 2. It's 10:30 at night. Lunch review number 2. But I'm doing these during lunches with my kids. Hopefully they're coming for review. Not all of them are coming for review, but some of them are. For those that don't, it's found at www.nkinfinity.com. All right. Just come over here. First of all, hit the subscribe button before you do that. Come over here to New York State Teachers. Hit the review. Go down. This one says Regents Review. If you click on this middle one, Regents Review, that's going to take you down here at the bottom, and you should see eventually my lunch reviews 1, lunch review 2, lunch review 3. I'm going to do like 8 of them, I think. I got 8 of them. There's going to be lots more work. I hope this is helping you guys out. I really do. I sort of miswrote this first question. I should have said something at the end here. I forgot that M is in terms of months. All right, so how does this problem work? This problem's a pain in the neck. I don't even know why I started with it. All right, so blah, blah, blah. My YouTube channel is increasing by 9% over the previous year. I'm hoping this continues. If it does, over the next month, which expression could be used to represent the monthly percent increase in subscribers? So here's the problem. This is a yearly percent increase. So I need to figure out what 1/12 of that interest rate is. Now, of this percentage is. So I need that interest rate to be 1/12 of what it is. So instead of being 1.095 as a growth rate, I need 1/12 of it because I only want 1 month. And then if I raise that to the M, I should get that. Well, 1.095 to the 1/12th power is this one. That is not a nice question. It's kind of a nasty little question. Let's move on. Let's assume I purchased 100 shares of Google stock 20 years ago. Oh my goodness, would I be a rich person today? And by the way, it wouldn't be worth $31,000. It would be worth a lot more than that. Anyway, let's say I spent $45,000 and I checked online to find out the stock is worth now $31,200. Assuming exponential growth to the nearest 1/10 of a percent. What's my growth rate to the nearest 10th percent? So I'm going to use the equation A of t, accrued value, is equal to PE to the RT. It's kind of a simple equation to use. My final amount will be $31,200. We're going to start with, remember, P is always your principal or starting amount, $4,500, E to the 20R. Well, if I want to find this, I got to get the weird thing alone. This thing is the weird thing. So I'm going to get this thing all by itself by dividing by 4,500. Now, I'm not really going to divide this, but I might get rid of those zeros. Now, I don't need to divide it. I need to just leave it, because if you divide that, then you're going to round it, then you're going to be off. Just leave it. It's 312 over 45. If you want to put the zeros back in, go ahead. E to the 20R. Now, in order to solve an equation that has a variable that is an exponent, you need to use logs. So I'm going to trust log base E. Now, I know it's base E, and in fact, the calculator won't even let you put that in, so there's no reason to even put it there. And then these two things switch side. I'm going to take the log of both sides, so log base of 312 over 45 is equal to 20R. Then I'm going to divide by 20. So, let's see what that looks like. So, the natural log of 312 divided by 45 equals divided by 20 point. And this is going to give me 0.096817. So R is equal to 0.096817. Now it said rounded to the nearest 1/10 of a percent. So don't be silly, don't be crazy. You got to get this thing over. You got to get it into a percentage. So we're going to move this over here by multiplying by 100 to turn into a percent, and I get R equals 9.7%. All right, hopefully got that one right. All right, so this was a kind of a tricky question. I saw this one on an old Regent, so I just rewrote it a different way. So the equation represents the value of a jet ski after T months of ownership. Oops. T months of ownership. Sorry about that. Hopefully that's a T. Which statement below is not correct? Well, the start value of this thing is 12,000. That's pretty easy. This is correct. So let's get rid of that. This is probably the next easiest one. The jet ski after 1 year, except that it's not in terms of years, it's terms in months. So I need to take 12,000, multiply it by 0.83, and raise it to the 12 over 12. Well, that's just 1. So really, I'm just taking 12,000 and multiplying it by, I can't seem to get to my calculator. 12,000. And multiplying by 0.83. I can raise it to the 1, but that's just 12. 9960, 9960, that's fine. So these two talk about monthly. Now, if this is 0.83, that's really 1 minus 0.17. So that might lead you to believe that it loses 17% of its value in a month. But if it loses 17% every month, what, in about 10 months it's going to be worth about $10? That doesn't really make any sense. But let's just check it out. Let's put in 1 month. Let's see what is the value of this thing after 1 month. So we're going to take 12,000. We're going to take 0.83 to the 1 over 12. That's 1 month. Okay, let's see what we got. We're going to raise this to the 1 divided by 12. And I get $11,815, $11,815.11. Now, what was it worth originally? Well, it was worth originally $12,000. So let's see what percent is that. Divide by 12,000. And I get 0.984. So it's retaining 98.4% of its value. So this one looks like it still works. So here's the one that is false. Although I'll bet some of you picked that one as the answer. All right, the maggot populations of a well-ripened garbage can triple in population every 4 years. The poor, the Dupreys. By the way, I don't know if you know the Dupreys from Hilton, but they are some crazy good wrestlers. Crazy good wrestlers. All right. We got a Dupre at our building that's ranked number 1 in the nation. That's Louis Dupre. And his younger brother Sammy's just a sick wrestler as well. So they're good wrestlers. And they don't have maggots on their trash can. But they could. Who knows? So let's say they didn't know about it and they left and they had 250 maggots on their trash can. And it's tripling every 4 days. Well, if they come back from vacation 21 days later, how many maggots are on their garbage can? Besides how much did they throw up, how many maggots are on their garbage can? Okay, let's try this one. So anytime you do an exponential problem, you're going to start with the initial value. The initial value is, let's see, accrued maggots. So accrued over time. How about maggots over time? That's even better. We'll do maggots over time is equal to our starting value, which is 250. Now, our growth factor is tripling. So what I need to put in the parentheses is 3. If it was doubling, I'd put a 2. If it was quadrupling, I'd put a 4. If it was a half-life question, I'd put a half. Okay, in this case, I'm tripling. So I'm going to triple this thing. And I want to. Now, the exponent on these kinds of questions is always the tricky part. You have to look for the every week, every day, every 2 days, every 2 hours. In this case, it's every 4 days. So every 4 days. So that means in 21 days, if I divide by 4, that tells me how many triplings I'm going to do. So when you're working with the exponent, the denominator is always the every word. Every 5 days, every 2 hours, every 6 minutes, whatever it is. In this case, it's every 4 days. So I'm going to put 4 down here. And time goes in the numerator. Well, the time they told us was 21 days. Now, when you do this, you're going to get a ginormous number because tripling is huge. So 250, we're going to triple this sucker, and we're going to raise it to the 21 divided by 4. And we end up with that crap. I hate when this calculator does that. 79,000. When I did this in class, the kids were like, what? 951. Now, I can't have a half a magnet, so that's it. 79,951 maggots. We're done. Moving on. According to Wikipedia, by the way, this is not true at all. I just made it up. Wikipedia, the NFL, an injured NFL player loses about 80% of their net worth just 2 years after they leave the NFL if they're playing. If an NFL player is worth is $10 million on their last day playing, which expression below can be used to find their net worth in 2 years? So they're going to lose 80% of their net worth in 2 years. So if I take 10 million, which was my salary last year, and I multiply it by 0.2, not by 0.8, but by 0.2. That'll tell me my current net worth. So I like just punching in numbers because it makes me feel good. Not. So 10 million times 0.02. Boom. 200,000. You should have known that. So I need the one of these answers that's going to give me 200,000. My guess, it's probably not 3 or 4 because those would be too easy. It's probably one of these crazy ones. So let's do 10 million e to the negative 0.4. Negative 0.4. Nope, that's a lot more than that. That's 6,703,000. That ain't gonna do it. So let's do it to the negative 1.6. Oh, 201,000. Wait, 2 million. 2 million. Oh, this isn't 200,000, by the way. This is 2 million. What am I doing? This is 2 million. If I go back up here. Oh, come on. It should be 2 million, by the way. If you noticed, I put this in as 2%, not 20%. So it should be 2 million. So I'm looking for 2 million. There's the one that's 2 million right there. Sorry about that, kids. Got a little crazy with my zeros. There's the right answer right there. All right, moving on. Again, you should try these ones on your own. I'm going to stop this, and I'm going to come back. You should try these ones on your own before I do. Well, I sincerely hope you paused this one and tried it on your own before you came here. Because this isn't that bad. It's a little crazy, though. A little cray-cray. The trick is we got to start with this. We're going to convert that thing. So we're going to leave this one the way it is. And you got to convert it. Now, you got to remember, roots are in the ground, power up. So this is 5 over 4. Roots in the ground, power up. So my power goes in the numerator, and my root goes in the denominator. Is equal to m over to the 8/7. I'm really almost done with this problem now. I got to get rid of this by dividing by negative 2/7. Now, when you divide two things that have the same base, you subtract their exponents. You subtract their exponents. So 8/7 minus negative 2/7 is really 10/7. So I end up with n to the 5/4 equals m to the 10 over 7. Now I still want to algebraically solve for n, so I need to get rid of that 5/4. The way I get rid of that 5/4 is raising it to the reciprocal. Don't say multiply, but raise it. Now, in effect, what you're doing is you're multiplying the exponents, because exponents raised to exponents, you multiply them. Well, those multiply to give me 1. So I end up with just n equals, and now if I get 40 over 35 here, which is really just 8/7. And that's the answer. Let's do another one. Again, we're going to convert this one first. So we're going to rewrite this as 27. Now we got to be careful on this one. The only thing being raised to the power is that. So this is x to the 6th, all raised to the 1/5 power. Yeah, this one was nasty. 1/5 power is equal to y to the 3/5 power. And we want to solve for, determine and state y in terms of x. So now I want to get y by itself. I'm going to raise this to the reciprocal, 5/3. 5/3. So these cancel. So I end up with y equals, now these 5's cancel, and I end up with 27x to the 6th to the 1/3 power. Now I should have said in simplest form, so let me simplify this. This is really just the cube root of 27x to the 6th. Well, 27 is a perfect cube, and so is x to the 6th. The cube root of 27 is 3, and the cube root of this is x squared. So really, y is equal to x squared. Woo, that was a tough problem, actually. That was pretty tough. All right, let's move on. Let's move on. Let's move on. Let's move on. We're going to move on. The latest medicine to treat the feeling of vertigo after surgery has a half-life of 9.023 hours. The medicine, in order to be effective, must maintain a minimum of 18 parts per million. When first administered to a patient, the concentration is 74 parts per million. Totally made up problem. I have no idea. All I know is vertigo makes your, like, it messes with your ear or something like that. Makes you all over, like, trust me, I don't want it because it, like, makes you queasy. It's like me being on a roller coaster. But anyway, let's talk about a half-life formula. All right. So my, let's see, my accrued value or whatever over time is equal to my starting value, which is 74 parts per million. It is a half-life, so 1/2. Before I had tripling, so I put a 3 there. Now it's a half-life question. Now it half-lifes every 9 hours. There's the everything. So remember, everything's go in the denominator. In the numerator goes my time, and in this case, it's 10 hours. Well, that's almost a full half-life. It's a little over a half-life. So this will probably end up being somewhere around half of 74, which is about my age. Not. 74, parentheses, 1 divided by 2, parentheses, raised to the, I'll put this one as a fraction, 10 divided by 9.023. Press enter. 34.3246. 34.3246,837. And we want it rounded to the nearest thousands of place. The thousands place is this one. And since that is this is a 6, we're going to round it up. So 34.325. Boom. Shakalaka. That's the concentration in parts per million. Now the next question says, how many hours rounded to the 10th of an hour before the patient should be administered another dosage? Well, to maintain the effective rate. Well, the effective rate is 18 parts per million. So I want my final amount to be 18. I'm going to start with 74, 1/2. I don't know time this time, so I'm going to put a t there, divided by 9.023. All right, you know if your variable is an exponent, you're going to be using logs. All right, so let's get the weird thing alone. Don't take offense to that. Everybody's a little bit weird. Trust me. I know, I'm really weird. So there we go, and a little crazy myself. So we're going to get the weird thing alone by dividing by 74. Now, I am not going to put 18 over 74 in my calculator. I mean, if you do that, you get some obnoxious decimal. Don't do it. Leave it. Leave it as 18 over 74. That's fine. Now, in order to solve an exponential, I need to turn it into a log. Log. It's all about that base, about that base, about that base. In this case, the base is 1/2. 1/2 goes down here. Now, these two things are going to switch sides of 18 over 74, and that's an 18, equals t over 9.023. So now I got this crazy stuff on over here is equal to this. Well, how do I get rid of this 9.023? Oh, I'm going to multiply this side by 9.023, and I'm going to multiply this side by 9.023. And so that's what I'm going to put in my calculator. 9.023, parentheses, control log, not natural log. What happened there? 9.023 times parentheses, control log, not natural log, of 1/2, 1 divided by 2, of 18 divided by 74 equals 18.402, so that's 18.4 hours, round to the tenths. All right, how we doing? We got 2 left. 2 left. Okay, kids, let's talk about Lindsay. She is an amazing basketball player here in Hilton, and this is sort of a true story. I have no idea about the $20,000. That would be awesome if they did, but who knows. But she did miss a sectional basketball game when she was crushing it the game before, but quinceañera is pretty important in their family, so that's awesome. So Lindsay's grandparents, on the day of her quinceañera, I misspelled it the other day, so that's okay, which is her 15th birthday, and that becomes actually important later, gave her $20,000, even though she missed a sectional basketball game. We were sad. Lindsay, having learned about the importance of saving early, decided on 2 investment options. Option 1 will pay her 4.05% interest compounded annually, and option 2 will pay her 4.01% compounded quarterly. So we have to write these equations up differently. So let's talk about option 1. I'll call it A of t. A of t, you always start out with the same thing, starting out with your principal value, whether I do A of t or B of t. Now this is compound, first one is just annual interest rate, so it's really just 1 plus 0.04. I hate 4s. I know you guys have been with me for a while. No, I hate 4s. 0.0405. That's this interest rate written as a decimal. Remember, you got to divide by 100. Raised to the t. Oh, they said n. We got to use n. So let's use n. We'll use n because that's what they told us to use. If you don't use, by the way, n, you get it wrong, which kind of stinks. So now we're going to use b of n. For option 2, call it option 2. This one's a little trickier. It's because it's compounded quarterly, you're still going to start out with this $20,000, but it's going to be 1 plus. Now, because it's a quarterly interest rate, or because this is a yearly interest rate, we got to change it to a quarterly interest rate by taking 0.0401 and dividing by 4. But because I divided that by 4, I got to divide the years by 4 because I'm breaking every year up into 4 little increments. So each part gets added. So that's like 4 times as many little increments. So 4n. All right, so that's the first part. Lindsay plans to leave the money in the account for 10 years and use it to pay for a trip around the world when she finishes college. Apparently she's going to be in college for a while. Well, 10 years, that'd make her 25. Well, okay, she's going to be in college for a little while. Maybe she's going to be a doctor. She's really smart. She'll probably be a doctor. So let's figure out which one gives us more money. So let's do A of 10. 20,000. 1 plus 0.0405 to the 10. Let's do that one. 20, parentheses, 1 plus 0.0405, parentheses, raised to the 10. It's 29,000. Ooh, that's pretty good. $29,747 and 52.52 point. Because this is not my final answer, I'm not going to round it just yet. Now let's do option 2. Option 2 is B of 10. So we're going to start with the same thing, $20,000. 1 plus 0.0401 over 4 raised to the 4 times 10. So $20,000, parentheses, 1 plus, now we're going to do control division, 0.0401 over 4 raised to, I assume you guys can do 4 times 10 and make it 40. $29,806. $29,806 and 7713. Now, clearly this is the better choice. It's slightly higher. So we're going to take that. We're going to subtract. Oops. We're going to subtract off this. And we're going to round our final answer, $59.25. So you need to write, my head's probably in the way, option B is better by $59 and round it correctly, 25 cents. All right. Algebraically determine to the nearest tenth of a year, how long will it take for the better option to triple her money? Oh, I guess we didn't use the 15 years. I thought it was using this one. We want to triple her money. Well, she started out with $20,000. Yay, Grandma and Grandpa, you're awesome. And then we're going to triple our money, so we want to have $60,000. So, starting with $20,000, we're going to use option B, right? We're going to use this equation. Parentheses, 1 plus 0.0401. Hopefully she's going to get this done in her lifetime. We'll see. To the 4t. Now, we don't know what t is, so that's what we're looking for. Get the weird thing alone. Let's divide by 20,000. Should come as no surprise for those of you that have done these in a while. I just added too many zeros. This is a 3. So 3 equals 1 plus 0.0401 over 4 to the 4t. Now, because this is an exponential equation, I have to solve it using logs. So logs, it's all about that base. So log, now this crazy thing right here is the base. Don't get that sweat. Don't make that crazy. Don't make that, look, oh my God, what is that? That's the base. 1 plus 0.0401 over 4. These two things are going to switch sides. Of 3 is equal to 4t. Divide by 4 and divide by 4. We're almost done. So log, control log, of, I'm going to put it in parentheses, 1 plus 0.0401 divided by 4 of 3, enter, divided by 4, enter. It's going to take 27.53 years. So t is equal to 27.53 years. Round to the nearest tenth of a year, 27.5 years. So in 27.5 years, Miss Lindsay will have tripled her money. Last problem. Alrighty, here we go. We all know that Superman's only weakness is kryptonite. Lexi Luthor, after one of my students, strung a 2.5 kilogram piece of kryptonite around Superman's neck. The half-life of kryptonite, half-life, that means our base is going to be a half. Don't forget, we need the every. The half-life is every 9.25 hours. That's the half-life. Superman is able to lift 200 grams of kryptonite, thus freeing himself from the danger. So that might come into play. Write a formula defining all the parts that will give the mass of the kryptonite over time. So mass over time is equal to our starting amount. Now we got an issue here. This is grams. This is kilograms. We have to stick with 1, and it's easier to turn kilograms into grams. So 2.5 kilograms, since 1 kilogram is 1,000 grams, that's really 2,500 grams. It's a half-life. Now, remember, it's a half-life every 9.25 hours. Hope you're getting good at this. Time over 9.25, where m of t is the mass of kryptonite in gram. That's just terrible. Kryptonite in grams. And t is time in hours. I had to do that because the problem said I got to define my variables. All right. How much kryptonite to the nearest hundredths will be around his neck after 24 hours? So we're going to say, okay, the mass of 24 after 24 hours is equal to 25 kilograms, or 2.5 kilograms or 2,500 grams. 1/2 to the 24 over 9.25. So we grab our calculator. We go, okay, calculator. 2500, parentheses, 0.5 is a half-life, parentheses, raised to the 24 divided by 9.25. 5. Enter. So 413 so m of 24 is equal to, round to the nearest hundredths, 413.89 grams. So the question says, how many hours rounded to the nearest hour before the amount of Superman, the amount of kryptonite, before Superman can free himself? So we know that he can only free himself if the amount of kryptonite is 200. We're going to start with 2500, half-life of 1/2, T over 9.25, right? Because we got to end with 200, start with 2500, and we just don't know time. Apparently, we're going to have to do logs again. So we're going to divide by the 2500, the weird thing. Get the weird thing alone. I'll get rid of those zeros, but I'm going to leave that as 2/25. It's fine. So now it's log base 1/2 of, and then these two things switch sides, 2 over 25 equals T over 9.25. Now, how do I get rid of that 9.25? That's right, multiply both sides by 9.25. And so that, my friends, if we can be called friends, is going to be what we put in our calculator. 9.25, parentheses, control log, base is 1/2, 0.5 of 2 divided by 25. It's going to take 33.7 hours. So time is going to be equal to 33.7 hours. Now, if that came out to be 33.1 hours, we would have to round to the nearest hour. Well, it says round to the nearest hour, so that's not great. Let's just do T equals 34 hours. That's the answer. Thanks, bro. Must have done a video in a tie. Anyway, that's the end. Hit subscribe, hit like, let your friends know about this, tweet it out, text it out. Let's get going. All right, guys, catch you all on the flip side. Goodbye.